All right, let's walk you through the answers on the midterm. All right, here we go. How many oxygens are in the formula? That is a simple, remember that whenever you see the NO3 in parentheses with the 2 subscript, that means the same thing as NO3, NO3. You see the 6 oxygens there, which is a polyatomic ion. This is just a recall of a polyatomic ion. What does it mean? It means more than one atom, all with a negative or positive charge. Identify the correct order of attractions among particles in the 3 states of matter. Remember that solids have the strongest forces of attraction. That's why they're solids. So the correct answer there is solids is greater than liquids is greater than gases. Which particles are in the nucleus? Remember the nucleus contains protons and neutrons. Electrons are outside of the nucleus. Isotopes are the same atom, so they have the same number of protons, but they have a different number of neutrons. That's what makes an isotope an isotope. The following equation is an example of, this is a nuclear equation where we take 2 smaller species and bring them together. That is nuclear fusion. Fission, remember, is the breaking apart of a larger nucleus. You circling the answer to this question is an example of kinetic energy. You're moving. When plants convert carbon dioxide into oxygen, the process is an example of either a chemical or physical change. We're actually converting the chemical from one to another. That's chemical. Which of the following is a transition metal? That's just remembering the transition metals are there in the center of the periodic table. That would be copper. Identify the missing particle in the nuclear decay. Remember that we add all the numbers on the bottom and they have to equal on left and right. That means the bottom number here would be 17. The numbers on top have to equal, and since that's a 0, that would be a 34. Atomic number 17 is chlorine, absolutely. So we're looking at chlorine 34 there. Which element is found in teeth? The best answer here is fluorine, but credit was also given if you put calcium. Which of the following is a macronutrient? Again, this is a little bit of memorization here. For food, sodium is considered a macronutrient. Chromium 51 has a half-life of 27 days. You start with 8 grams. How many grams will remain after 81 days? What the half-life means is I'll have 4 grams in 27 days, and then in another 27 days, starting at 0, which is 54 days, I'll have half of that, or 2 grams, and in another 27 days, which gets me to the 81 days, I'll have 1 gram. 14, what is the shape of CH2Cl2? That's a carbon with 4 things attached to them, 2 hydrogens and 2 chlorines. You could have drawn out the Lewis structure, but you didn't have to finish it if you recognize that 4 things around the carbon. That's a tetrahedral. Number 15, blank, is how close a measurement is to the true value. That's what we mean when we say accuracy. 16, what is the length of the cylinder below? This is reading our centimeter ruler. Remember, this is in centimeters, and we're not trying to trick you there, but it's how many decimal places. Each one of the marks on the cylinder is the ones place, and so in between the mark would be a second decimal, and it looks like here I am between the 2.7 and the 2.8, and so the best answer here is 2.75, giving me that second decimal in between the markings. How many hectoliters are in 100 milliliters? This is remembering those unit conversions, either memorized or you've got the mnemonic memorized. I'm starting with 100 milliliters. I have to convert it, cancel the milliliters, convert it to hectoliters. Hectoliters. And hectoliters is a tenth, and that's 1,000. And so when you plug that in, you end up with 0.001. Let me double check, see. So then I don't have to, yeah, how about 0.01? All right. Oops, no, 0.001. I should have plugged it in my calculator. Plug it in, make sure you get that. What group on the periodic table is silicon? Recognizing silicon is Si, and you just find it on the periodic table. I'm looking over at mine, and that is group 14. Normal human body temperature is, you might have this one memorized, it's 37 degrees Celsius. You could have eliminated a couple of these. 67 degrees Celsius is awfully hot. Remember, room temperature is 25 degrees Celsius. So that would have gotten those. Most people do know that it's 98.6 is normal human body temperature. So it's not 99, it is 37. Phase change for the following reaction. We are going from gas to solid. That is deposition. The opposite would be sublimation, going from solid to gas. That one caught me a couple times when I was working through this. When a metal gains electrons, it is said to be a little bit of memorization. If you used oil rig or whatever, gaining electrons means he's reduced. He gets more negative charge. What is the correct name for the following? We can count our carbons, 1, 2, 3, 4, 5, 6 in our longest chain. So it's not the pentane, it's the hexane. You'll notice that both of the remaining answers have the 3 methyl groups, trimethyl, so it's just which numbering system do I number from this side or from that side? And we want to number from the side that gives us the lowest set, and 334 is smaller than 344, and so the correct answer there is C. What is the relationship between the following compounds? I've got the one on the right. It's got an oxygen in it. This one has an oxygen in it. It does just have 1 carbon at the end, but notice this one only has 2 carbons to the left. That one has 3 carbons to the left. They are not related. They're not isomers, or else they need the same formula of any type. They're not the same compound. They're simply not related. In the following redox reaction, which functional group is being oxidized? Oxidized means oxygen is being added to it, and it did highlight it here for you. I don't know if you saw that on your test, but I went from here to here. There's where my oxygen was added. This is one of the reactions that you had to memorize. And so this functional group that is being oxidized is an aldehyde. All right. In that same reaction, what is copper 2 being reduced to? Copper plus 2 is going to the copper in this compound, and that must be a +1 in order to get that formula, 2 of them. And so he's being reduced to the copper +1 ion. 26, in an oligosaccharide, how many glucose units? This is a little bit of a memorization. Remember that you've got monosaccharides and disaccharides, and oligosaccharides contains anywhere from 3 to 9, and then you've got another word for 10 or more you call poly, and so the answer there is 5. That's in that range. Again, a little bit of memorization. Blank is a disaccharide found in beer, and blank is a monosaccharide found in cranberries. Again, just kind of a recall. That's maltose and mannose. 28 is a recall. The sweetest monosaccharide and the most common disaccharide. You've got fructose and sucrose. 29 is also a little bit of a recall. You may have more familiarity with this. A person with B-type blood could receive O, which is the universal donor. 30 and 31 refer to those reactions. Reaction 1 it's either endergonic or exergonic. In reaction 1, it's going to lower energy. It's releasing energy. That's exergonic. And then as I compare the speed of the two, since this one is endergonic, it has a larger activation energy than that one. So reaction 2 with a larger activation energy is going to be slower. Number 32, a recall storage polysaccharide found in the liver is glycogen. A structural polysaccharide found in exoskeleton is a chitin, or chitin. Alkenes contain single, double, triple. Alkenes are the double bonds. The products of combustion are, remember that a combustion is if you take oxygen and a hydrocarbon as reactants, you get carbon dioxide and water as your products. And which of the following will not make a reaction go faster? The only one of those that will not make the reaction go faster is agitation. Enzymes, that's their purpose. Heats will make reactions go faster. If you increase the number of reactants, it goes faster. All right. Here we have our fill in the blank section. What units must be used to compare amounts of two different chemical substances? That's your mole mountain. You've got to compare moles to moles if you have two different chemical substances. List the 4 steps of the scientific method in order. You first make an observation. Well, this is all recall. And then you provide a hypothesis. You do an experiment. Of course, you needed to write these out. And then once you do the experiment, you come up with either your conclusion or you make a theory, and then this begins the process over depending on what that conclusion was. All right, silver 110 has how many of each of the following? You've got to remember that silver is Ag. Look it up on the periodic table. It's atomic number 47. On the periodic table, it's got that 47 above, which means it has 47 protons. If it's neutral, it also has 47 electrons. And since its mass number is 110, that's given, 47 minus 110 is 63 neutrons. Consider the following 2 ions. The cation, that's the positive guy. This is the silver Roman numeral 1 ion. SO3 with a -2 is the sulfite ion, not the sulfate, but the sulfite. And if I put them together, since the sulfite ion has a -2 charge, I will need 2 of the silver ions to balance it. And the name is simply the name of those 2 ions put together. So silver, Roman numeral 1, sulfite. Balance the following chemical equation. Notice you do have to show your work. So I go down and I grab, I didn't leave enough room. All right. I can treat the phosphate as a unit since he shows up in both places, or I can treat him individually. And so over here on the right, I can either keep him together or treat him individually. I'm going to go ahead and treat him individually. So I've got 3 sodiums. I've only got 1 phosphate, 4 oxygens, 1 magnesium, 2 chlorines. On the right, I've got 1 sodium and 1 chlorine. I went ahead and wrote them in the same order as on the left to help me understand them. Get rid of that so you can see clearly I've got 2 of the phosphates and 8 of the oxygens and 3 of the magnesiums. All right, so I just go down the row, starting with one that's going to be easy-ish. Let's do sodiums. How about a 3 there? That makes 3 sodiums. That also makes 3 chlorines. All right, I can go ahead and do phosphorus. I've got 1 over here and 2 over here, which means I need 2 sodium phosphates. Now notice that messed up a bunch of them, so let me fix them. I now have 6 sodiums, 2 phosphoruses, and 8 oxygens, which messed up my sodiums, which I'd already fixed, so I can fix them now or fix them later. Let me go ahead and fix them now. Keep that there. So my next step would to say, well, now I need 6 of these, which gives me 6 chlorines. So my sodiums I have refixed. My phosphoruses are good. What about my oxygens? My oxygens are good. Let's go on to magnesium. I have 1 magnesium on the left, 3 on the right. So if I put a 3 there, that gets me 3, which gets me 6 chlorines, which, hallelujah, bam. There is a 1 here, but I don't have to show it. I can leave that blank. All right, back and forth, back and forth. Number 43, write the formula for the following compound and state whether it is ionic or covalent. So do a little scratch work here. Calcium phosphate, that is an ionic. I'll go ahead and label that. Made up of the calcium ion, which I have to know is +2, and the phosphate ion, which I have to know is PO4 with a -3. All right, which means to put them together for my answer, I'll need 3 of those calcium ions and 2 of the phosphate ions. There is my final answer, and it is ionic. All right. Insulin is a protein that is used by the body to regulate blah, blah, blah. A bottle contains 125 milliliters of insulin at 50 milligrams per milliliter. What's the mass in grams of insulin in that bottle? So how many grams is in that 125 milliliter bottle of insulin? And there is my equivalence. I'll need milliliters on the bottom and milligrams on top, and that's 50 milligrams in 1 milliliter. And I'm looking for grams, so I'll change that milligrams to grams. In 1 gram, there are 1,000 milligrams, and I will punch that in my calculator, and you end up with 6.25 grams of insulin. Number 45, what is the total dose of aspirin required in milligrams? So how many milligrams equals that 108-pound patient if it's this many milligrams per kilogram? So I'm starting with 108 pounds. I am going to need to get that pounds into kilograms of body weight. So the milligrams is the dosage of the aspirin. The weight of the patient, I need to get to kilograms, so I'll go pounds to kilograms if I know that off the top of my head. Or if I look at it on the sheet. All right. And then once I've got the kilograms, then I'll use that conversion factor to do kilograms to milligrams. And there are 34 milligrams per 1 kilogram. That's what that number means. And so I punch that in my calculator. I get 1665. I should go to 3 significant figures. So 1670, or I can write it in scientific notation. All right, number 46, convert 78.34 degrees Fahrenheit into Kelvin. You do need to convert it into Celsius first. The degree Celsius plus the 273 equals the degrees, or you don't write the sign, equals the Kelvin temperature. So first thing I'm going to have to do is Fahrenheit to Celsius. So I have to know that formula. To get Fahrenheit to Celsius, I take the Fahrenheit temperature and I subtract 32 and divide by 1.8, and that gives me my degrees Celsius. That's the formula. If I punch that in my calculator, I end up with 25.74. I'd have to do the subtraction first, and then I divide by 1.8. And then if I add 273, 25.74, that's in degrees Celsius at this point, plus 273, and then I'll round, go ahead and round, keep the 2 decimal places. I end up with 298.74 Kelvin. Number 47, how many grams of sodium are in 2.3 times 10 to the 26 atoms of sodium? Sodium is Na. In order to get from atoms of sodium to grams, I have to go through moles. So this is moles of sodium, and 1 mole is 6.02 times 10 to the 23rd. This is my atoms. I'm just writing the symbol, but it's atoms, which cancels. And then once I have the moles of sodium, I take that to grams using the molar mass from the periodic table. If I look at sodium on the periodic table, it's about 23. I'm going to go to 2 significant figures for my final answer. I end up with 8787 ... grams, some decimal places there, or 8800, or I could write that in scientific notation, going to 2 sig figs. How many grams of calcium are in 4.52 grams of calcium sulfide? So how many grams of just calcium are in 4.52 grams of calcium sulfide? Calcium is +2, sulfide is -2, so that's CaS. I'll need to take grams of calcium sulfide to moles of calcium sulfide. Remember, to get between calcium sulfide and calcium, I've got to go through moles. This is the molar mass of calcium sulfide that I look up on the periodic table. Then I convert moles of calcium sulfide to moles of calcium. I do have to show this step, even though it is 1:1. And then I would convert moles of calcium to grams of calcium. Using the molar mass from the periodic table, that's about 40. Punch that all in my calculator. Let's go to 3 significant figures, that original question. And I end up with 2.51 grams of calcium. Number 49, calculate the density of an object in grams per milliliter with a mass of that many kilograms and a volume of that many centiliters. So the density is grams per milliliter. So I'm going to have to take kilograms to grams. So let's do that first. 2.3 times 10 to the 3rd kilograms. So that's my problem. So how many grams? Kilograms to grams. There are 1,000 grams in a kilogram. Or you could do 1 over 0.001. That is fine. That's 2,300,000. Lots of zeros. You could write that in scientific notation. Then let's take the volume to milliliters. So how many milliliters is 850 centiliters? That's a unit conversion. Centiliters on bottom, milliliters on top. All right, that's 8,500 milliliters. And now I'm ready to calculate my density. It's this many grams. So 2.3 times 10 to the 3,456 grams all over 8,500 milliliters. Punch that in your calculator. Looks like we need to go to 2 sig figs, my 2.3 kilograms times 10 to the 3rd kilograms. To 2 sig figs, I get 270. Again, you could put it in scientific notation. Draw the Lewis structure for the molecule below. I think we're getting close to the end. Ooh, we got quite a few left. All right. C2H3Cl. This is a carbon-carbon bond. You have 3 hydrogens and 1 chlorine around them. And so the 2 hydrogens would be on this carbon. A hydrogen and a chlorine would be on this column, carbon. You still need, if you count up valence electrons, this is going to need a double bond and lone pairs around the chlorine. And the fact that there is a lone pair, the fact that there is a chlorine on one carbon and not the other, chlorine is more electronegative than carbon and hydrogen. This is polar. The shape of the molecule is more kind of that way. All right, you got trigonal planar around each of the carbons with sort of that end being positive and toward the chlorine is negative. So you needed to indicate that in your drawing. All right. Draw the skeletal structure for 3-bromo-1,1-dimethyl-cyclohexene. I'm going to start at the end. A cyclohexene is 6 carbons, and there is a double bond, and that will be in the 4 position. So 3, 2, 1. So I'll number like that. In the 1-1 position, is a dimethyl. So my 1 position is right here. Let me get rid of that one so I can see the dimethyl. In the 3 position, there is a bromo group. So let me get rid of that number 3 and stick a BR there. And so that is my final answer. Yours might have been upside down or whatever, as long as the numbering scheme still worked. All right, draw the product of the following reaction. You have hydration across the double bond. Essentially, the water adds across that double bond with an H on one carbon and the OH on the other. We're talking about these 2 carbons. Since this right-hand carbon already has more carbons on it, that's where the OH is going to go. So I can kind of draw that. This will have an OH. There will be a single bond now. And this carbon will have an additional H, which I don't have to draw. So you can draw something like that. There were a couple of other ways that you could have represented that would also be correct, as long as you're sort of showing where all the carbons are. What is the name of this reaction? I said it just a minute ago. This is a hydration across that double bond. It's also an addition reaction. You might have used that word. Draw the products of the following reaction. We have a reaction when you add water and acid to an ether like this. Again, the water breaks that bond. You actually have the breaking of that bond. And so you can think of let me get different colors. This portion and this portion go their separate ways. And on the left-hand portion, I now have an OH on that oxygen. And on the right-hand portion, I now have an OH on that carbon. And so I have something like that. All right. Draw a square around the anomeric carbons. This is the carbons with 2 oxygens. And so I'm looking for a carbon that has 2 oxygens on it. And the only one that fits the bill, I've got an oxygen there and an oxygen there, so this guy gets a square. If I look over here on the right, I've also got this carbon, which has an oxygen and an oxygen. He also fits the bill. So there are 2 anomeric carbons. I want to circle the glycosidic bond. The glycosidic bond is the bond that connects the 2 sugars. So essentially it's the bond, let's see, OH. It's one of these bonds, this one or the other one, that connects those 2 sugars. And then label the glycosidic bond as alpha or beta. This bond in this direction, this group is up, but this group is also up. Since they're both up, it gets labeled beta. All right. Circle and label the 5 functional groups in the following molecule. Mark each chiral center with an asterisk. All right, I have a benzene ring or an aromatic. I have a thiol, and you should be labeling these. This is a thiol. With the NH next to the double bond O, this is an amide group. This is an alkyne group. And this is an isopropyl group. And I'm looking for chiral centers. I'm looking for carbons with 4 different things attached to them. And there aren't many. Nothing on the aromatic ring or the benzene ring will be chiral because they've all got double bonds. Nothing with a triple bond or a double bond will be chiral. The carbon over here, oops, wrong thing. The carbon over here in the isopropyl will not be chiral because he's got 2 methyl groups attached to him. So let me not mark him. The only carbon that's got 3 different groups is that one right there, if you kind of go down the line. So there's your only chiral center in this molecule. All right. I'm going to do a separate video for the bonus questions.